Hi, I'm Li Hao. So in the last video, I talked about custom stores, in which the value of the store slowly moves from the current value to the target value that you are setting it with. I explained how you could write such a store, and in the end of the video, I show you that you could actually use the built-in methods from Svelte, like tween and spring, depending on what kind of movement that you want to. In that video, I didn't explain in depth about how what are the possible ways that you can use tween and spring, in which it does not do them justice. So in this video, what I'm going to do is I'm going to show you how you can use tween and spring and make full use of them. So the first thing I'm going to share with you is tween. So let's take a look at this REPL that I have prepared for you. So over here, I imported both tween and spring, but right now we are looking at tween first. So in tween, so right now I am not using anything. I'm using a writable. So when you have a writable, when you change the value of the store where you try to assign a value to it, it will turn into that value immediately by itself. Right? So there's no transition from the current value to the target value. But if I import tween from Svelte Motion and I use that instead of writable, now as I change the value, you see that it slowly moves towards 20, right? And I change to 0, it will turn to 0 slowly. So here is, so the second parameter of tween is actually options that you can adjust the tweening. So first thing is you can adjust the delay. So for example, if I set delay in milliseconds like 500 milliseconds, then the value does not change until 500 milliseconds later. Next thing is duration. If I set the duration to be 5000 milliseconds, which is 5 seconds, then it will take 1, 2, 3, 4, 5. Okay, my counting is bad. But as you can see, it takes 5 whole seconds to reach from 0 to 20. Now next is the easing. The easing is a function that describes how the number, the acceleration, the rate of the number changing from the current value to the next value. So if you don't pass it easing, then the value is moving linearly, which means it moves in a moves in a constant speed. But if you pass in a custom easing, for example, right now I'm going to import cubic in from Svelte easing. Now you may not notice, but the number actually increases in an increasing speed. Right? It stays at, for example, right now I am at 20. You'll see that it will stays at 20. Okay, let me remove the delay. But you'll notice that for example, from 1 to 20, you'll see that the number stays at 1 to 2 a very long time, and then it starts to accelerate and moves faster and increase faster, and all the way it shoots up like a curve over here, and it reached 20, probably a very short time from 15 to 20, right? So pay attention, right? It stays at 1 for a very long time, and then suddenly it shoots up and then it hits 20. So you can control all these different kind of easing using a different easing function. So the next option we have is called the interpolate. Before we move into interpolate, let's take a look at what are the type of values that you can pass into tween store. Right now, in most of my examples, you see what I've done is I tween from a number to another number. So I start with an initial value which is a number, and then I set it to another number. But it does not have to be just a number. It can be other data types. For example, it could be an array of numbers. So I have say 1, 0, 50, and I want to interpolate to, I want to set the target value to be say 100 and then maybe 0, right? 100, 0. If I click this, you can see that both numbers will change together at its own speed, right? So 0 will move to 100 and 50 will move to 0. So if I remove the easing and delay, let me just comment them out. You can see that it's both numbers are moving right towards their target number in 5 seconds. So you can have a number, you can have an array of numbers, and then the next thing is what you can have is actually object where the values are numbers. So for example, I can have an object, say A is 0, B is 50, A is 100, B is 0. So all the property value has to be an, oops, sorry. Let's see, how should I do this? Because this will be interpreted as a expressions which I don't want. So probably I will use HTML and just do this instead. Okay. So I have a object with two properties, 0 and 50. A is 0, B is 50, and I change. Both properties will be updated at once, right? So you could have more properties, right? But then because C is not there, it is undefined initially, then you have error. But right now, if I set C to say 40, hold on. This is not, okay, I think I made a mistake over here. This should be null and 2 so that this is multi-line. Okay, let's take a look at how this 3 property interpolates to each other. Right? Just to make it clearer, let's update the button as well, the button text, but although it does not make any effect. So right now we change from 0, 50, 40 to 100, 0, 30. Right? So you can see that all the numbers is being interpolated at the same time. Okay, so besides object where its property is numbers and arrays which its item is numbers, you can actually have each of them nesting each other. So for example, I can have array of numbers over here, 50, and turning into 30, 70. See, it still works. All the numbers still changing. Or I can have array of objects over here instead. And maybe another item, A equals to 40. And here is A equals to 30. I change. All the numbers are still interpolating correctly. So as long as the number of items matches, the number of properties is the same, and each of the property has the same type. For example, number matches with number, array matches with array. The built-in tween function will able to handle all of them nicely, right? And lastly, it's not just about numbers. It can be about time. So if I have new date over here and new date, say 0, right? And I change. You can see the time will move, will be tween as well. So numbers, dates, object with keys is numbers, arrays where its object where its value is numbers, and array in which the item is numbers, and nested of either nested object array or array nesting with object. What else? Basically, I think that's all. So if you try to change it to string and try to interpolate, you can't interpolate string. So that's where that option called interpolate comes in. So interpolates is an option that allows you to add more features to tween to tell them, okay, I'm getting a number or I'm getting a string, and here's how you can tween them. Here's how you can interpolate them. So for example, let's make our example simple. I start with a string which is A, and I want to set it to Z, right? I want to set A to Z. So if I change, I can't interpolate string value. So over here, I can implement a function called interpolate, which is a function that takes in which takes in A and B and returns another function that takes in a T and then returns something that you need to implement over here. So what's A, B, and T? So let's print this out and take a look. So A, B, T. So A is actually the starting point, B is the target point, and T is the value from 0 to 1. So as you can see here, A is Z because you start with A, and then B is actually Z itself, and then the T is the time from 0 to 1, so which is the position where like you are currently at from 0 to 1. So it will start moving from 0 and all the way to 1. Right. So for example, right now I want to tween from A to Z, then what should I do? Well, probably I can do something like this, where I can maybe interpolate in terms of the characters. So for example, A's char code at 0 is a number, right? A code. And B code is b.char code at 0. And then I can interpolate between these two numbers. So I will say the result code equals to A code plus B code. Alright, sorry, it's a B code minus A code times T plus A code. So we get the difference between A and B, and then we type. So if it's 0, and then we plus times T and then plus A code. So A code, if T is 0, then what you get will be just the value of A code, right? But if T is 1, which is the target value, then this will be B code minus A code plus A code will release you to B code, right? So this is standard format of how you would write interpolation. So with the char code, we are going to convert it back to its own character. So the char code has to be an integer, so we are going to round it. So math.round result code, and to convert it to a character, I'm going to say a string.from char code. I'm going to return this whole thing. And let's see. We'll change from A all the way to Z, right? So if I change this Z to A, okay, so I'll change A to Z and then change it back to A. Cool, right? So you can write your own interpolation as long as you follow this function. So let's summarize what we have learned so far. We have seen how to use the tween method to create a tween store. So the first parameter is the initial value and second parameter is the options, in which you can control the delay, duration, easing, as well as interpolation. We have seen what can be supported by the built-in tween, what can be interpolated by them, and we also seen how we can write a custom interpolation function. So next, let's move on to the spring methods. So allow me to copy this. And let's take a look at the spring store. So again, spring is like a writable in which you can change its value. But by default, when you change a value, it changes the value directly. So if you use spring instead, then your value the value moves like a spring. And a spring has actually properties like how stiff the spring is and how much resistance the spring has. So these two values is being summarized by stiffness and damping. So for example, if my spring is very stiff, which means that it will snap back to the target value very quickly. So for example, let me just choose average value like a 0.5, and maybe damping is also 0.5. Let's see what we get. So if the stiffness is, if you have a higher value in terms of stiffness, the value will snap to the target value faster. So let's see, if I start from 0.2, you see that you will move slightly slower. And if I go for a higher number like 0.9, then it moves faster to the target value. Of course, if it moves faster, which means that it will also overshoots and then snaps back like a spring. And then damping, which means damping is a function for slowing things down. So it works in an opposite pair of your stiffness. So if you have a very small number, for example 0.2, which means that it will decrease in terms of velocity slower. So you will see a spring moves oscillates a lot. But if you have a higher number, for example 0.8, then your spring will not oscillate that much and then settle down faster. So these are the two values that you can play around with spring. And over here we set the value, right? So when you set the value, it will move to that target value. But sometimes you want to move to that value but without springing to that target value. So how would you do that? So you can do that by coming back to the sets method. So value.set. So if you write $value variable over here, where you assign value to 20, it actually means value.set 20. But you can't, in this way of writing, you can't actually specify the second option arguments if you have. So here we fall back to value.sets because we want to pass in a second argument. And the second argument that you can pass to a Spring store is first is an object, and the first is you can have a property called heart goes to true. This heart indicates that you want to move to that target value immediately without making like a spring where it springs to that value. For example, if I move to 60, it's like a spring, 80, and then at 40, it's like hard jump to that value. And opposite of hard, what you get is soft. So value.set 60 soft. So you might ask, like, if you assign a value, it's already moving like a spring to that target value, right? Then what's the point of having to pass in soft? Well, I'm not able to show you particular in this example. We can't really see the difference. But then the difference is this: when you set soft, you actually tries to maintain the speed of the moving value. For example, if I'm moving from 0 to 100, and then I quickly click 60, it will maintain the speed you will maintain the speed, and instead of setting 60 as a target value and try to snaps to 60. And how long do you want to maintain the speed will be this value that you pass into soft. So this soft actually tells you 0 to 1. You can pass a value from 0 to 1, indicates like how many seconds it takes to recover to turn back to become a spring. I know it's a bit abstract, and personally I also can't tell the difference visually, but that is how it works. So for example, if I say I pass in 0, which means that it takes 0 time to convert back to a spring, and which means that this actually is the same as calling value equals to 20, right? Value equals to 60. So setting soft to 0 is actually the same as setting value to 60 without passing any soft, because you take 0 seconds to recover back to become a spring, right? And if it's 1, then it takes like 1 second. So that is it. That is all the options that you can pass in for spring. So let's summarize about spring is you can control the stiffness and the damping of your spring. She controls how much it will spring and how much it has resistance in slowing it down, right? And then you can have options like hard and soft to control whether you want the springs to kick in when you change the value or you want it to be disabled just for the moment. So that's all for this. So if you like this video, give me a thumbs up, and I would love to see you come out with any examples that using spring or tween in your code. So if you have any examples that you want to show, comment them down below. And as always, subscribe to my channel so that you get notified when the next one is out. So see ya, bye bye.